And welcome everybody to today's Cosmology segment. I'm your host Dan, aka smAsho, and we decided to make the Cosmology segment first today because of the timing of the annular eclipse that's occurring. Well, it's just starting as we make the video. So we'll talk about that toward the end of the segment, how to find it. First, let's talk about NASA rejecting missions to the moons of Jupiter and Neptune. So we immediately covered NASA's missions to Venus, and they are upcoming. If you're wondering what missions they turned down, they're to two outer planet moons. So Neptune's moon Triton and Jupiter's moon Io, the most volcanically active body in the solar system, were turned down. Now, of course, it would be, interesting for NASA to have sent a mission to Io. Perhaps it would have taught us something about volcanism on Earth, as it's believed that the extreme heating from its close orbit is what creates the largest volcanoes in the solar system on Jupiter's strange moon Io. So anyway, Io orbits Jupiter at only 350,000 kilometers above the cloud tops, so very close to the planet. That's only 100,000 kilometers farther away than the moon is from Earth, to give you some perspective. I don't know, maybe that doesn't give you any perspective. Triton is also a weird place. And Neptune only has one large moon. It orbits its planet backwards. And I believe many people think that the possible ocean under the surface of Triton is actually an ocean of ethane. But in any case, Triton is a weird place. It may be covered with nitrogen snow. So in any case, have a read on that if you like. This is an article from SciTech Daily showing you some interesting graphics about both Io and Triton, two extreme locations in our solar system. Next, the astronomy picture of the day showing a crepuscular ray ring. And the reason you get this ring is because of the direction and polarization of the light coming through the atmosphere. It creates this round ring due to the ice crystals in between the sun and your location on Earth. Those ice crystals create different refraction patterns, and when you have a homogeneous layer of cirrus clouds like this, you're most likely to see these sorts of sun halos. And down in this area, you can actually see some rainbow colors there. It must be for the month of June. It's what you would call a sundog if you only saw that little portion of the arc. That's NASA's astronomy picture of the day. You can check it out yourself at apod.nasa.gov. As we count down to the solstice, we are now in the 20 brightest days of the year, or if you're in the southern hemisphere, the 20 darkest days of the year. Make sure you join us when we do a live stream at 11:32 p.m. in 9 seconds. We will be streaming live to wish you a happy solstice at the moment of the solstice on June 20th. We picked a random number, and today's random number is DK Draconis, a cataclysmic variable type star. And here's a paper about it from 1982. And don't shy away from papers just because they're old, folks. DK Draconis is an interesting star indeed. It's a binary system, and this study is talking about its calcium-2 and hydrogen and potassium emission lines and so on. Perhaps have a read about DK Draconis. Here's some imagery of it. It's number 407 at the Neil Gorell Swift-Bat X-ray Observatory. And here it is in infrared light, and you can see how it's got this feature down here. And over here, it looks like some sort of a stellar outburst. Something like a giant cloud of ionized plasma close to its stellar sphere. If we look at it in different wavelengths, you won't see that feature at all. Here it is in blue light. And here it is in infrared. Great view of the heat radiation coming out of DK Draconis. And again, that is number 407 at the Neil Gorell Swift Bat X-ray Observatory. BAT stands for Burst Alert Telescope. There are the historic X-ray transient outputs from it. You can see it's quite a variable X-ray source here on the daily scale, but fairly consistent on the longer term. That's a 16-year chart. Follow your favorite objects at the Neil Gorell Swift Observatory, if you like. Let's talk about galactic cores. Turns out that black holes can affect things outside of their galaxies. Let's do a little bit of an illustration here. This artist's rendition of a galaxy here may have galactic jets, and these galactic jets may be roughly perpendicular to the galactic disk. Let's just say that this one does have jets, and that they come out in this sort of a perspective. Now, if this is the size of the Milky Way galaxy, you're looking at something like about 125,000 light years in diameter here. And so if you have this galactic jet contacting other material in this area, you're talking about tens of thousands of light years away from the galactic core, having an effect via these jets. They're essentially particle beams blasting out primarily protons. They are cosmic ray sources indeed, the most epic cosmic ray sources in the universe, the jets of the supermassive radio sources at galactic cores. So perhaps read this article if you like. This one is on phys.org's Astronomy and Space section. It's an interesting day for cosmology. Anyway, it's not exactly understood the full mechanism behind how these jets are generated. It appears to have something to do with the magnetic fields and the relationship between the toroidal region and the poloidal region of the galactic cores. But in any case, a great collaboration here between two communities, the observers and the theorists, which in the field of extragalactic astrophysics are finding that cosmological simulations are a useful tool to understand how the universe behaves. Here's a quote. "Not only can we observe the effects of the central black holes on the evolution of galaxies, but our analysis opens the way to understand the details of the interaction," explains Navarro, who is the first author of the article. The way galactic supermassive radio sources at the cores of galaxies can affect things even beyond their own galaxies. Probably no surprise to most of our viewers. Let's talk about fast radio bursts. Which is weirder, a one-off fast radio burst or a repeating fast radio burst? Well, they're both very interesting for different reasons. And we see all kinds of different radio bursts coming out of the sun. So when it comes to regular everyday solar activity, we look at the 10.7 centimeter radio flux. When it comes to coronal mass ejections, one of which we just saw last night, and indeed a proton event strike, when we look at those, we look at a 245 megahertz radio flux, and we typically see radio storms associated with major solar outbursts from the sun. Sometimes it even gives us the ability to forecast things when we see these radio bursts. Now, last night we saw a short radio burst, and it was of little warning from the sun as we saw relativistic protons strike the Earth's geospace. But in any case, radio bursts are super important in that it's not understood how they're generated either. And locating the repeaters' sources is super important as well, so we can study the sources of the repeating radio bursts. There are some powerful radio stations out there in space, and the CHIME telescope has detected over 500 of them in the past year, its first year of operation. So applause to the CHIME project. How about a changing look Blazar? You want to see something really weird? So a Blazar is a type of active galactic nucleus where the poloidal jet is pointed directly at you, the observer. And check out the changing look Blazar. This is absolutely bizarre. Check that out. Here's what it used to look like. And then here's what it looked like after that. It's, yeah, multiple outbursts here associated with this diffusion of the light coming from the Blazar. Very interesting. Not understood. I'm going to let this paper scroll so you can read it if you like. Quote, Blazars are a unique kind of active galactic nucleus with very powerful jets. Jets are a radio mode of feedback, and because of their scales, they penetrate the galaxy into their large-scale environment. The origin of these jets and processes driving the radiation are not well known. Thus, studying blazars allows us to understand these jets better and how they're connected to other components of the active galactic nucleus, like the accretion disk. These jets can heat up and displace gas in their environment, affecting, for example, the star formation in the galaxy, or certainly the stellar outputs. So, at the end of 2017, this blazar exhibited a huge optical flare, a phenomenon captured by the All-Sky Automated Survey for Supernovae Telescope Network. So they followed this up by observing the evolution of its spectrum and light curve over the next 2 years and retrieved archival data available for the object. With data spanning over a decade has yielded some exciting results. We see dramatic variability in the spectrum and multiple transformations between the two blazar subclasses for the first time, giving it the name Changing Look Blazar. In addition, we see many very large multi-band flares in the optical and gamma ray bands on different timescales and new spectral features. Such extreme variability in the spectral features demand dedicated searches for more such blazars will allow us to use the dramatic spectral changes observed to reveal active galactic nuclei/jet physics, including how dust particles around supermassive radio sources known as black holes are destructed by the tremendous radiation from the central engine, and how energy from a relativistic jet is transferred into the dust clouds, providing new channel linking the evolution of supermassive black hole with its host galaxy. They're excited by the results of discovering a new changing look blazar that transforms itself not once but 3 times between its 2 subclasses from the dramatic changes in its continuum emission. Also, new spectral features and optical variability is unprecedented. It's really interesting to see the emergence of a forest of iron emission lines also. How come so many iron emission lines appeared? So that is super interesting. Was the iron suddenly created in some sort of an outburst fusion event? Or was the iron there the whole time only to be illuminated by this sudden variability? In any case, another fascinating article about changing look blazars, good enough to be featured on today's thumbnail. Next, talking about the annular eclipse. It's pretty serious, and it's just started just a few minutes ago from when we made the video. So today, on Thursday, June 10th, people across the Northern Hemisphere will have the chance to experience an annular eclipse when the moon is too far away to completely cover the sun. They're also known as ring of fire eclipses. And we've covered this on previous videos. This is what an annular eclipse typically looks like, folks. And if you head to timeanddate.com, you can see their coverage of it. It begins in about 25 minutes. We'll be actually recording our daily space weather video at the time. Remember, folks, don't look directly at an eclipse. If you've got eclipse glasses, check it out using those, or use the pinhole projection technique. Anyway, thanks for tuning in to today's Cosmology segment. I've been your host, Dan, a.k.a. smAsho, and we'll see you next time here at the Smash News Network. Least busted, name and news.